Hi, my name is Eric Jerde, and I am a graduate of the University of Missouri St. Louis College of Optometry. I graduated in 2012, and I appreciate the opportunity to submit a video to you. The question is, why do I want to be a KMK optics instructor? And I've always really enjoyed mathematics. In fact, before optometry school, I was considering, do I want to be an optometrist or do I want to be a math teacher? And I was given a great opportunity at UMSL, and I took full advantage of that. And I'd like to definitely give my shot at teaching here. And I think that I have a lot to offer too, because my teaching method is not just about giving a PowerPoint or reading off slides, and there's a lot more to teaching than that, because you have to engage yourself. You have to shoot for a little bit more than just the person sitting in the room nodding. I'm shooting for the O factor. I'm shooting for someone to say, well, no one's ever explained it to me like that, because that's when you realize that you're getting a level of understanding. That's when you know you're teaching. What can I add to KMK? I don't teach memorization. I teach comprehension. I teach application. I teach simplification. I want to prepare someone for the curveballs that the test is going to throw at them. If you change one or two words, it's not going to change how the people that I teach, how they're going to approach that question, because they're not just memorizing. Someone that memorizes is going to get thrown off. And that's why I like teaching the way I do. I feel like there's a better understanding of the concepts as a whole. The other thing that I feel like I can bring to the KMK team is the goal of visualization and kinesthetic learning. I feel like auditory can only go so far. I'm not a very good auditory listener, so I had to teach myself visually and building and making things 3D for myself just to understand some concepts while I was learning. And I feel like I can take some of those things that I taught myself with and share it with others, because to this point it's been very successful in the tutoring that I have done, including for the class of 2013 and 2014, this most recent year. So those are the things that I'd like to show you in how I teach a lesson plan here. So we're going to go over how to do a power cross. Now you go, okay, power cross, that's a pretty simple example. But with a power cross, it's easy to get mixed up, and I found myself constantly getting mixed up. So there's a really easy way, and what I want you guys to do is to take your marker or your pen, and I want you to draw a line from here to here and just go boom. Now, you're going to remember that. Every time you do that, you say boom. In your head, right now I want you to say it out loud. Ready? Good. All right. So when you do that, you're telling yourself, I am taking this number and I am putting it here on my power cross. So I'm going to take my -1 and put it in the meridian of 180 there. Now, what goes up here? Well, that's, you guys all remember the -1, -2, you add those together, so we got a -3. So I don't have to think now, am I putting the -1 here? Is it 90 degrees away? What am I doing there? This is an easy way. Just take this standard script notation and do your boom line, all right? So let's go down here and let's apply it to a new example. What do we do? Boom, all right? So I put my +4 in the 90th meridian. And then I take these two numbers, add them together. I've got two power crosses I did in 20 seconds total. It's that easy, guys. So what do I have over here? Well, we've got a power cross, but we've also got an axis cross to remember. So yes, it can get confusing, but if you know that you're always doing a power cross first when going from this notation, you can put a little P right here, and that's going to help you remember. That's my power cross. My axis cross is over here. Axis cross comes to play when we're doing retinoscopy, and I'll go over that next. But with the axis cross, it's actually 90 degrees away from our power cross. That's all the axis cross is. Let's go down here. We move the +4 90 degrees away, and we move the +11 90 degrees away. Wow! All right, so we've done two power crosses, two axis crosses, in about a total of a minute with me talking too. What I want you guys to do is to write down these phrases. I want you to write power equals meridian. Power equals meridian. I also want you to write power equals induced. So when we're doing a power cross, we're talking about where the power is actually induced. Let me explain this further. Axis, I want you to write this, guys. Axis equals orientation. Axis equals orientation. You can also write axis equals at, because a lot of times you'll say at when you're talking about axis. So let's talk about the difference between axis and axis and power. The axis is always 90 degrees away from the power, and the best way to visualize this is with a plano cylindrical lens. Plano cylindrical lens is going to be a lens that has 0 power along one meridian and an induced cylinder power along the other. Notice I said induced power in the other meridian. So I've got some Krispy Kreme donuts here that represent my cylindrical lens. I like this versus drawing because I can spin it around and look at it and even smell it because it smells delicious. But let's take a look. If I look right down here, you see this right here, this ridge. It's the ridge of the lens here that I can describe as the axis of this lens. Notice it's flat. I can just take my finger and just lay it flat across the top of these donuts here. That means there's 0 power along this axis, okay? 0 power along the axis, but if I take this 90 degrees away, you can see now that there's this curvature here where the power is induced. 90 degrees away, power's induced. Axis, 90 degrees away, the power's induced. Let's go back. So my axis, -1 here, the power is induced 90 degrees away. Axis over here, induced power 90 degrees away. All right? Let's go a step further. Retinoscopy. You guys all know how to do retinoscopy now, but what are we doing? We're actually doing an axis cross with retinoscopy. What do I mean? If my streak is oriented, axis equals orientation, if it's oriented vertically and it neutralizes with a +3 lens, what I can do is write down +3 right there, okay? That's my axis. I can even draw a little A right there, my axis cross. Now, if the streak is oriented horizontally and I neutralize with a +1, I put that on my axis cross, because axis is the orientation, it's the retinoscopy cross, and I've got a +3 and I've got a +1. So if I want to change that to my power cross, remember it's 90 degrees away is the induced power. See, it's that easy, guys. So let's just draw these powers 90 degrees away from where they were. Now if I've got a retinoscopy distance of 67 centimeters, that's the same as 1.5 diopters. You can just do 1 divided by 0.67 and you'll see that it's 1.5 diopters. And what I do is I subtract 1.5 from each of these to figure out what my actual power is. So minus 1.50 gives me plus 1.50 here, and it gives me a minus 0.50 here. Okay, see how I did that? 1 minus 150, negative 0.5, and there. So then what I want to do is figure out, okay, how do I write this in notation? Well, let's do reverse boom, okay? It's going to be a plus 1.50 minus, how do I get to that? Well, I subtract 2 diopters and I can get from plus 1.50 to negative 0.5. So I'm subtracting 2 diopters. Reverse boom here. I wanted to have my boom, so my 150 was at 180. Look how easy that is. So if I go back and I say boom, I put the 150 right there, it works out perfectly. I could also do this for minus 0.50, and you'll find that it works out like this. And check it by going boom. All right? I'd like to thank you guys for giving me an opportunity to teach, and I hope that I get an opportunity to talk with you a little bit further. Have a good day.